This is video number 4 on related rates. This will be the last video from this chapter. And we're going to look at example 280. And example 280, we are filling up a cup in the shape of an inverted right circular cone. So it's just a cup in the shape of a cone. And we are given some information about the rate of change of the volume, and we are asked information about the rate of change of the height. Now for this particular problem, we're going to have to work with similar triangles again. And so I've drawn a picture, and again, do not put constants in your picture for things that are changing. The width of the cup, 5 centimeters, is not changing. The height of the cup, 10 centimeters, is not changing. This part here, this smaller cone, this represents the water. So we're filling the cup up with this water. The radius of this circle is changing, and the height of the water is changing. Now, we're not being asked anything about the radius, and we're not actually given information about the radius, but we put this here because we're going to use similar triangles so that we can express the volume in terms of the height. So when we look at this, we have a right triangle right here, part of it's dashed, and then we have a smaller right triangle right here. Again, they're right angles. They share this angle right here, so they are similar triangles. And so we have our proportion, r divided by 5, so the lengths of the corresponding sides, r and 5. r divided by 5 is equal to h divided by 10. So that's the height of the water divided by the height of the cup. This proportion gives us the height in terms of the radius. And so the radius in terms of the height as well. So the radius is 1/2 h. Volume is 1/3 pi r squared times the height. This is a formula for the volume of a cone. And we're talking about the volume of this cone here. We're given its rate of change. Now, because r is 1/2 h, we substitute 1/2 h for r. That is why we put r in the picture. So now we have our volume in terms of our height. So it's just a polynomial. Volume is pi divided by 12 h cubed. So now we differentiate implicitly with respect to time. So we have dv dt is a derivative with respect to t of 12 over pi h cubed. This is dv dt. Here we use the power rule, so we just multiply by 3, decrease the exponent by 1, multiply by dh dt, because h is a function of time, so is volume. They are both functions of time, so we take the derivative of each one with respect to time. We are given that the volume is increasing at a rate of 2 liters per minute. Remember, a liter is 1,000 cubic centimeters. So this 2,000 is given to us. This is the rate of change of the volume. This is the rate of change of the height. This is what we're looking for. We are given that h is 5. So we want to find the rate of change of the height when the height is 5. So here we have 5 squared. That's where the 25 comes from. So now we have a constant equal to a constant times dh dt. dh dt is what we're trying to solve for. So dh dt is 320 divided by pi. So the height is changing at a rate of 320 divided by pi centimeters per minute.